Hi everyone, let's see one of the question on synchronous counters. Consider the following state diagram which is to be designed using T flip-flops for MSB. MSB means what? Most significant bit. XY flip-flop for LSB, least significant bit, right? So the behavior of XY flip-flop is given below and the state diagram they have given clearly here, right? Means here they are trying to construct one kind of a counter where the counter contains the most significant bit side that they would like to use T flip-flop and the least significant bit side they would like to use XY flip-flop, and that XY flip-flop behavior also they have given, right? So guys, so far we have seen to construct any kind of synchronous circuit either through all flip-flops are of same type, right? So all flip-flops are of same type only we have seen. But the thing is, we can able to use the combination of flip-flops also. That's the reason they have mentioned here as MSB bit for T flip-flop and LS bit for XY flip-flop. For example, if you want to have clarity, they are saying that if you take the two bits, one is MSB bit, another one is LSB bit. LSB bit side they are going to use XY flip-flop, and this is LSB flip-flop. And for MSB flip-flop they are trying to use T flip-flop. They are trying to use the T flip-flop, right? So for example, if you are going to assume this is Q0 and it will be the Q0 bar, definitely this is Q1, it will be the Q1 bar, right? As we are going to consider them as synchronous, we can able to pass the clock signal. Here they haven't mentioned, but we can go with the synchronous counters, right? Yes. Now what you have to do, how they will be connected, you have to define first, right? Then this circuit will follow this particular thing. So now this is the meaning of this one, right? So basically you have to go with the, whenever you're trying to construct any kind of synchronous circuits, you have to go with what kind of flip-flops you have to find. So they have given clearly that it is of type T flip-flop and XY flip-flop, and you have to find out the excitation table for the given flip-flop, right? So if you go with the T flip-flop, so you know the excitation table for T flip-flop, right? So the excitation table for T flip-flop is, if I am going to have Q1 and Q1 plus 1, if it is T 0 0 0 1 1 0 1 1, so this is latch and these two are toggle states, and you have to find out the excitation table for now XY flip-flop. Excitation table for the XY flip-flop. How can we construct the excitation table for the XY flip-flop? You have to know its characteristics, right? So for that they have given the function table already. Function table. From the function table, guys, this kind of question we have seen earlier, right? So you have to implement some kind of XY flip-flop using JK flip-flop. At the situation we have seen this particular processor. You can go through the earlier video, you can get the idea, right? So first what you can do now, you can try to construct the characteristic table for this. Characteristic table for the function table, right? If you go with the characteristics table, how can we get XY? It might be Qn and it will be the Qn plus 1. So what might be the possibilities? 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1, right? What might be the Q1 plus 1, right? If it is 0 0, they are always going to produce 0 irrespective of its state, right? If it is 0 1, it is going to produce always Qn. If it is 1 0, it is going to produce a Qn bar. According to this I am trying to write. If it is 1 1, it is always going to produce the set state. Yes, this is the corresponding characteristic table. From characteristics table, can we able to draw the excitation table? Yes. How can we do this? Meaning that for the kind of Qn and Qn plus 1, what might be my X and Y? That is what my question. So possibilities are 0 0 0 1 1 0 1 1. If it is 0 0, if it is 0 and 0 0, the values are 0 and pi. You can get the idea. If it is 0 1, 0 1 means this is 0 1, this is 0 1, so you have to have 1 pi. 1 pi, right? If it is 1 0 1 0 and 1 0, that is 0 0 0 1 0, so that will be the pi 0. Similarly 1 1, you have to take out these two cases, 1 1, so I think pi and 1, fine, right? So this is what the excitation table. Once we complete with the excitation table, you can go with the state diagram. State diagram already they have given, right? So then you have to go with the circuit excitation table, right? So circuit excitation table, you can go with simply what might be the present states. The present states might be Q1 and Q0, right? Next states can be Q1n and Q0n, right? 0 0 0 1 1 0 1 1. So if I am going to have 0 0, how it is behaving? It is moving to 1 1. If I am going to have 0 1, how it is moving? It is going to go for 1 0. If it is going to have 1 0, how it is moving? It is going to go for 0 0. If it is having 1 1, it is moving to 0 1. 0 1, right? Yes. So for this you have to have extend with the excitation tables, right? Excitation tables, one is for T flip-flop, another is for X, Y flip-flop, right? So go with the T flip-flop. So why it is T flip-flop? Because MS bit, right? MS bit is Q1 only, right? So T flip-flop. So try to write for 0 1, 0 1 it is toggling. I am writing. For 0 1 it is toggling. For 1 0 it is toggling. For 1 0 it is toggling. So the value of T will be always 1. What about the XY? The XY is 0 1. So for 0 1 case, you have to write down 1 pi. For 1 0 case, you have to write pi 0. For 0 0, you have to write for 0 pi. For 1 1, you have to write the pi 1. Pi 1, right? That's it. So now, so to construct the circuit, you have to go with the simplification. What might be the value of T? T value is 1. What might be the value of X? You have to note down with K maps and simplify it, right? So Q1 and Q0. So except 1 0, this is 0 1 0 1, except 1 0, 1 0 is this one. So remaining all are going to be considered. So before going to write, we'll try to solve everything. For 0 0 it will be 1 and these two are going to be pi, right? Then I can combine like this. If I am going to combine, you are going to get Q1 bar, right? So means X equal to Q1 bar. What about Y? Y will be Q1 and Q0, 0 1 0 1 0 1. So for 0 1 only you have to have 0, and for 1 1 you have to have 1, and remaining are going to be pi. Now you can combine like this, right? If you are going to combine like this, you are going to get Y equal to Q1. Y equal to Q1, right? Now once you have got the expressions, you can able to get circuit diagram, right? We have written this already, this logic diagram. You have to combine the values. So X value will be Q1 bar. X value will be Q1 bar. What about Y value? Y value will be Q1. That's it. So this is the corresponding diagram what they are expecting to create. Okay, I hope you understood clearly. Thank you.